Okay, so in this video I'm going to go over examples of graphing with phase shift. Some will have vertical translation, some will not. So for this one, the amplitude is 2, it's a cosine graph. Amplitude is 2. The period is 2 pi over b. In this case, b is 3. The quarter of a period is 2 pi over 12, which is pi over 6. The phase shift is pi over 2 over 3, which is pi over 6. So this one worked out nicely, where they already have the right denominator, or the same denominator, and there is no vertical translation.
Hi,
Okay.
I'm Andrew.
Okay. And then, so we're going to label the phase shift is 1 to the right, pi over 6 to the right. Okay, so every tick mark is going to be pi over 6. So I'll start here, pi over 6. 2 pi over 6 is the same as pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. And that's one period right there, 2 pi over 3. And then 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 is 4/3 pi. 9 pi over 6 is 3/2. And then 12 pi over 6 is 2 pi. Okay, so we made the phase shift is pi over 6 to the right, so that's one tick mark. It's a cosine graph, and that's where we're going to have our maximum point. So right here at pi over 6, it's going to be at 2. You count 4 tick marks over, so 1, 2, 3, 4. At 5 pi over 6 is the other one, the maximum. Okay, the zeros are at pi over 3, that's 1/4, and 2 pi over 3, that's 3/4. And at pi over 2, you have the minimum, which would be -2. Okay, and we need 2 periods, right? So we're going to keep going. So the pi is the next 0. The 7 pi over 6 is a minimum. The 4 pi over 3 is another 0. The 3 pi over 2 is a maximum, and that would constitute 2 periods. Now we don't leave the y-axis just alone without, you have to connect the graph to the y-axis. So that means that it's going to go through 0, 0. Following that pattern, connect your points. And so we have a little bit more than one period here, and that's okay. And here it is. So it looks like a sine graph. Like if I looked at this, I would say, oh, this is a sine graph because it has the, it goes through 0, 0. And that's it. Okay, so for example 2, remember tangent looks like this. Okay, half on one side, half of the period on one side, half on the other. Let's answer the 4 questions here, or 5 here. The amplitude we know is none, but we're going to use the -2. So A is -2. So that, remember, that tells you there's going to be a reflection over the x-axis. Okay, the period is pi over 3. A quarter of a period, 1/4 times 1/3 pi, is pi over 12. The phase shift is negative pi over 3. So what I'm taking this number divided by that number and then changing the sign. So negative pi over 3. Another way is to solve the argument, set it equal to 0 and solve for x, and you'll get this. Okay, the vertical translation is up 2. And remember, you have to make sure that the phase shift and the quarter period have the same denominator. These two, they don't. So the common denominator is 12. So I'm going to make this into negative 4 pi over 12. Okay, so every tick mark is a pi over 12. Okay, every tick mark. and so it's going to move 4 pi over 12 to the left. Okay, so let me just adjust the screen a little bit. Okay, so let's label the x-axis. So every tick mark is pi over 12. So the next one would be pi over 6, because it's 2 12s. 3 12s is pi over 4. 4 12s is pi over 3. 5 12s. 6 12s is pi over 2. So same thing on the left side, but with negative numbers. Negative pi over 12. Negative pi over 6. Negative pi over 4. And negative pi over 3. Okay? So phase shift is 4 tick marks to the left. So that's where for tangent, remember the 0 is right here in the middle. Okay, so it's right here in the middle. Okay, and so everything got shifted to the left. So the 0 that was at 0 0 is now at negative negative pi over 3. Sorry, right here. It's now right here. Oops, sorry, I almost forgot the phase shift. So let's go ahead and change that first. See, it's not. There it is. So it's up to right there. So as I was saying, the 0 is here because it moved to the left 4 pi over 12, 4 tick marks over. We count 2 tick marks to the right, and that's where the asymptote goes. So at negative pi over 6. Okay, and then we count 4 tick marks and draw another one. 1, 2, 3, 4. And then 4 tick marks. 1, 2, 3, 4. Okay, so now we draw the curves. So in the middle of the period is the 0. And then here at pi over 3 there's another one. Okay, and we'll just draw, we're going to actually end up drawing 2.5 periods. Okay, so now on this one would be the right side of the period, but remember there's a negative, so instead of going up like this, it's actually going to come down. Okay, it's going to be the opposite, it's going to be the reflection. So, and it's going to be negative 2, so negative 2 would be right here, and it'd go down, like that. Okay, at negative pi over 12, normally the left side goes down, but because of the reflection, it's actually going to go up, like that. So at negative pi over 12, it's going to go to negative 4, right here. And at pi over 12, it goes to 0, like that. And at pi over 4, it goes back up to 4. And at 5 pi over 12, it goes to 0. Like that. Okay. So what this looks like, it looks like a negative cotangent graph reflected over, or a negative tangent graph, but yeah, not like just like a normal one without any translation. Okay, and that would be the graph for this one. Alright, so here we have a cotangent graph or equation, and the amplitude is none, but we're going to use the 1/2 for our 1/4 and 3/4. Period is pi over 1/2, pi over b, which is 2 pi. A quarter of that would be 1/4 times 2 pi, which is pi over 2. The phase shift is negative 3/4 pi divided by 1/2. So that simplifies to multiply both top and bottom by 2, negative 3 pi over 2. Okay, vertical translation 1 down. Remember, cotangent looks like this. Okay, the phase shift and the quarter period have the same denominator. They both have a denominator of 2. See right here and right here. So we don't have to change any fractions. So every tick mark is going to be pi over 2. So this is pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, etc. Same thing on the left, but with negatives, negative pi over 2, negative pi, negative 3 pi over 2. So when there's a phase shift in cotangent, when we count backwards, like in this case, negative 3 pi over 2 for this number right here for the phase shift, it's the asymptote that moves along. In tangent, it was the we moved the 0, the point that was at the origin, and we moved it backwards. But right now, it's the asymptote that we move back. And so we move it 3 tick marks over because it's negative 3 pi over 2, so it goes right here. Okay? And then we count 4. 1, 2, 3, 4. And at pi over 2 is the other asymptote. So this is the end of the period. Count 4. 1, 2, 3, 4 at 5 pi over 2. And that will make up our 2 periods. I mean, we could draw a half of a period after, and that's okay, we'll do that. Okay, so, and then, oh yeah, and then the vertical translation is down 1. So it'll be right there. Okay, so now in the middle of the period is the 0. So at negative pi over 2, we have the dot. At negative pi is the part that goes above the midline, so right here. And at 3/4 of the period is the part that goes below the midline, so that would be right here. Okay, connect the points. Okay, for the second period, at 3 pi over 2 would be your 0. At pi would be 1/2 above the midline. At 2 pi would be 1/2 below the midline. And then you connect the dots, same way. And then at, I know it's not labeled, but the last tick mark, which would be 7 pi over 2, that would be our 0. And then what we have here are the 3 pi, that's the left side of the period, so that would be 1/2 above the midline, like that. So it's about 2.5 periods here, and that's cotangent.